The Electric Power Research Institute released a study stating that the overall reliability of the power grid in North America can be improved 40% by implementing a fully automated distribution system. Unfortunately, there are many hurdles between that vision and today's power grid infrastructure. One is interoperability. In order to realize the vision of a fully automated grid, we need common standards and protocols. I'm Alejandro Sznakowski with ABB. For the next few minutes, I'm going to discuss 3 ways the IEC 61850 standard does just that. Number 1, communications. There is a common perception in the market that IEC 61850 is a communications protocol. It is not, but it does provide a mechanism to exchange information between relays peer-to-peer via high-speed communications network without hardwired connections. This standard includes goose messaging, MMS, and sample measure values as 3 of the protocols that make up IEC 61850. With IEC 61850, all the engineering and documentation for goose messaging is in software. Instead of drafting plans, constructing, performing, and testing all these wires, which you would have to purchase, inventory, and physically engineer using existing methods, with IEC 61850, new configurations can be engineered on the software and sent to the devices via the Ethernet. Saves countless operational hours, plus you're documenting the engineering while you're designing it. One step. Number 2, substation configuration language and naming conventions. A second big driver behind the IEC 61850 standard is that existing protocols are not object-oriented. Data from existing protocols have no association with the actual application, equipment, or function they represent. For example, if you were to look at the position of a breaker utilizing the DNP protocol, you'd be looking at indexes inside binary inputs which represent the position of the breaker. Linking the protocol data to the application is an additional manual task inside the DNP protocol. However, using IEC 61850, the protocol data is contained within a virtual model of the function or apparatus where the data is contained. Now, when we look at the position of the breaker, there is a logical node which contains a data object that represents the actual position of the breaker. In context of a substation with thousands of data points, this provides a very structured way to organize data. IEC 61850 simplifies the engineering process by upwards of 30% versus existing standards. Number 3, conformance testing and system specifications. IEC 61850 provides system specifications with a very strict definition of the requirements for manufacturers to enable interoperability. The benefits for utilities is huge. By choosing to implement meters, relays, RTUs, and other devices that are IEC 61850 compliant for substation automation applications, utilities can select equipment based on operation and versatility rather than worry about whether or not it can interoperate with other devices. In turn, it minimizes risk of project delays during implementation and deployment while keeping equipment purchasing options open. There is no escaping the fact that at least some degree of grid automation is inevitable. Given that, the IEC 61850 standard is vital. It enables goose messaging between relays without hardwired connections, saving engineering and operations time and money. It standardizes a naming convention based on substation configuration language, dramatically simplifying the engineering process, and it provides conformance testing and system specifications that minimize risk of interoperability issues at deployment. Thank you for watching IEC 61850 Fundamentals. I'm Alejandro Sznakowski with ABB.